Hi guys, I am here with Lonni Besancon, a researcher at Linköping University, but located at campus Norrköping.
Yep.
You are trained as an engineer,
Yep.
but have now transitioned into something a little different than engineering, or?
Yeah, well, I started as a student, like working computer science engineering, and on the last year of my master's degree, I realized I could also do a master of research, which is something that we only have in France. And I went for that, working for human-computer interaction projects, so like how to design interaction with computers, smartphones, tablets, and then transitioned slowly into more meta-research projects, all the way through the PhD journey, let's say. And here I'm working on data visualization, interaction, and a lot of meta-research.
But what is it that you actually do for research? Because I've been reading your papers,
Yeah.
and a lot of it is both about the very technical aspect of it, but a lot of it is also how humans use it.
Yep. Yeah, it's right in between. So there's a lot of designing systems, so coding and designing systems that are smart or fast enough for things to work in what we call interactive times. So people don't have to look at their phone and wait for 3 minutes before something happens. But yeah, there's a lot of tests that have to be done to test that whether or not people actually like what we designed for them, whether they're more efficient in terms of time or completion time, what we call completion time, so the time it takes them to do something, or in the accuracy they have with this. But yeah, it can expand to a lot of different things. Like I worked for a while with people working with fluid dynamic data, and for them time doesn't matter, accuracy doesn't matter. What they want to get is something out of the data they have, which is really complicated, inherently 3D and really complicated. And for them it's just trying to find ways to interact with the data and something that's a bit more intuitive. So in this case it's just giving them a system and then trying to adapt it to their needs, all through process of creation of new design, and then like iteratively like change it a bit and a bit and a bit, and then getting to them thinking like, oh, okay, this is a neat thing. I can do what I used to do a bit faster now, and like this is more natural for me to interact with my data. This is quite interesting. And then
When you say interact with data, then what do you actually think about?
So there's lots of things like so if you imagine something that is 3D, if it's in the real world you can look around it, no problem, you can move around it, get it closer to you, like you can grab it, that's pretty easy. But when it's all virtual on a 2D screen, because when I started my PhD it was mostly 2D screens, right? AR was not a big thing, and all these headsets were not really there yet. So then you need to find ways to move your data around in this 3D space that's virtual. But also maybe like if you think about very dynamic examples, you need to go through your data, so you have these cutting planes that you need to manipulate to go through and inside the data to try and see what's there. But maybe also some other tools like these particle seeding things, so you put particles in a 3D model with, let's say, wind power, and then you would see the particles moving around with the direction and stuff, so they understand the data with all these tools. But like using it on a 2D screen with a 2D mouse is pretty difficult, because you need to specify your 3D point. And this is really difficult to do with a mouse. So
I'm like trying to wrap my own head around it right now. Like, it's okay, like 2D to 3D.
Yeah, it's pretty difficult. I mean, the way they did it was actually having a script that was MATLAB or Python, and they would put the coordinate with the keyboard and then try iteratively until they get to the right point. But like that would take forever. And we designed a system with which they had a tablet that they would move around in 3D that was tracked. So the tablet, when you move the tablet like this, the tablet would know that it had been moved like this. So you would move in the data, and then you just had to click on the screen. So X, Y was by the screen, but the Z was given by the tablet's position.
Nice.
And that's something they really absolutely love, because they went from spending 45 minutes figuring out how to place exactly the center of their particle seeding somewhere to just being like, and there.
Nice.
And for them that was something that was like, oh wow, this is great. And it's basically these kind of things, like interacting with data in a sense of trying to make sense of it through interaction techniques somehow. Like tools that you need to use in most of the time 3D.
If we as scientists have a high degree of imagination.
Yeah, because we're constrained by so many things. I'm not sure we are super creative people. I think it's one of the problems we have often. It's just that we are trained to be very thorough in everything we do, and being creative is the opposite of being thorough, I would say. You can have a creative process and try to follow it, but I would say it's the exact opposite of what we're trying to do. It's always following a method and always checking that everything makes sense all along the way, while being creative is like, maybe it doesn't make any sense, but I'm just going to go with it. Which is counterintuitive for us. If it doesn't make any sense, why would I go for it? You know, it's a waste of my time. Yeah. So I don't think we're very creative. I think that's why it's nice to have artists around. We can actually push through for some stuff, even though you're like first like, no, why would you? And okay, maybe that's cool.
Yeah. So maybe we scientists needs to have at least space for creativity.
Yeah, I think it's really important. The focus is really for us to write papers, and that's. I think in this context, it doesn't leave a lot of space for creativity. I mean, in some research fields maybe, but I guess in most it's just like, no, just stick to the thing that we know work and publish on this. And
yeah, which of course would get us into talking about the publication, which I know that you have some strong points on for making science more open.
Yep. Yeah, making it more open, more transparent. So basically making sure that all papers are accessible for free is the bare minimum, I think. It's weird to think of a system where we write papers, submit them, we review other people's papers for free, and we get to pay for the papers to be officially published, and then people need to pay to read them. And all of that money is taxpayers' money often. And it just goes to companies, and you just think of it like, wow, I mean, why are we paying them? If it's typesetting, they don't do typesetting anymore. Printing, they don't do that much anymore. And like paying $2,000 for a publication to be accessible online, I'm like, this is, I mean, there are real costs of publishing accessible online. It's basically closer to $200 or $300, I think, top of my head.
But do you think that because of the system not being open and transparent, that is also hindering some of our capacity to push science forward?
A big part of it, yes, because these big publishers, they also have this thing that they want the top papers, right?
Yeah.
So that means that if you want to have a career, you need to submit your work there. But if they consider this not top research, then your work is not published there, and it will stay in the pipeline for a couple of years before it's finally somewhere. And that's just slowing research overall. I mean, the peer review process is also something that's inherently flawed. There's lots of research on this. It doesn't really work out. It slows down science a lot. We're not transparent because the reviews are not accessible. I'm also maintaining a lot for reviews to be accessible after the fact. Anonymous or not, we can discuss that, but I think they should be accessible. If someone had to say something about the paper I submitted that maybe mitigated one of the point I was trying to make in my research, that it's not mitigated at all in my paper, then this review should be accessible for people to actually realize, oh yeah, I didn't think of this, maybe this paper is a bit too strong on that statement, you know? Yeah. I think it's really important this is out there. There's lots of scientific discussion that happen through the peer review process, and these are not available. And it's all in the hands of publisher again.
But if we go back to your science, because that is actually also very cool. Like if we talk about the archangel stuff. Yeah. Because I thought that when I read your paper on it, and then afterwards saw your TEDx talk, I thought that it does lead up to a lot of interesting ethical questions.
Yeah, there's a lot of them there.
There's a lot of them. So if we go back, then you are studying how that blurring or adapting images to become less offensive but still contain information.
Yeah. How they can be used for people to understand.
How that can be used, and there's a lot of very good applications for it.
Yeah, there's a ton of them. Yeah, but there's also very, very bad scenarios, I guess.
Yeah. So if you just briefly talk about what it is that you've been doing.
Yeah, sure. So, as you said, the idea is to try and automatically process stimuli. So it could be a video or an image. We didn't release a Google Chrome extension that does videos automatically, but we have it on images right now. But it works for videos, we tested that. And the idea is to automatically process things so that people can look at them without being disgusted. So if you think of a picture of, I don't know, abdominal surgery, you're gonna go in the OR because you're gonna be the patient, this is gonna happen to you, you wanna know what's gonna happen. And the process is documented online. I mean, Wikipedia has a lot of information. But if you try to look at it, chances are you're not gonna like what you're going to see very much. It's going to be quite difficult to look at. So the idea was to try and make this easier to look at while still keeping most of the essential information. So it's fine to blur out tiny details that don't matter, but maybe you want to keep this very important piece of organ that's there and that needs to be shown clearly. And we looked at different techniques that could do that automatically, one of them being this kind of drawing rendering, so it really looks like someone has drawn the picture. And it seems to work really well. We tested that on the famous data sets that are known to be difficult to look at. It seems to work quite well. And it could be used in a lot of different domains. So the doctor-to-patient communication is one, of course. But you can also think of content moderation online, which is something that's really problematic these days. There's a lot of reports on this. There's a lot of people being paid to look at very disturbing content 24/7. It's just going through videos of murders, rape, and way worse than this, all day long to try and see whether or not the content is suitable for the platform that they're working for, so Facebook, YouTube, Twitter. And this is a very difficult job, and we think that if we try to apply these techniques to what they see, because we still preserve some of the information, they should still be able to know whether or not the content is suitable for the platform, but at the same time it might reduce a bit the toll it has on their mental health, because it's a job that seems very, very difficult.
And that is... And one of the ways is, of course, you tested both altering the colors or making it look like an artist rendering, and came up with the comic book.
This kind of comic book rendering is very nice.
Which is sort of interesting because it's been used in comic books for generations.
And it seems that no one thought of that before. It's if you look at the comic books in the US, most of them are quite violent, and kids read that. It's very graphic very often, and they read that no problem. So we thought, okay, why not? The color alteration was something we thought would work, in particular in cases of surgery, because we thought that the color of blood was something that would put people automatically like, oh, blood. But turns out it doesn't seem to work much. It's not bad per se, it changes a bit, it's still a bit better. But nothing like the comic rendering, which is like, oh, okay, interesting. It was really an interesting finding. And it's a technique that looks cool. I kind of like it.
But it also shows that we've been used to it for a very long time. And now we just adapt it to a new media.
Exactly. It's pretty nice, and that's what people also mention because we made them, like random people like you and me, look at pictures that were not so nice. And they're like, oh that really looks less real because it's more of a comic book rendering, which was not I think the idea they had in mind when they developed that technique. It's not from us, the technique's not from us, something we picked from the literature. But I don't think that's what they had in mind, but it's true that it gives this comic book rendering, so people were super into it, saying that it's much easier to look at in the end. And
because it gives a distance between...
Exactly. It's more abstract, right? You're like, oh that's not real stuff.
Which of course then comes to the drawbacks, is that if we go through life without seeing real stuff. That's the Black Mirror episode there, exactly. It can be quite difficult. So in our case, the thing we developed is something that's online that the user can turn on and off whenever they want. Actually, you can leave it on all the time, but just right click on the picture and then it will come back to being the original picture. So we give them control to avoid this kind of never seeing anything that's shocking. But if you imagine that in 25 years from now everyone's going to wear glasses like this, but that would be augmented with technology, you could totally imagine that it would change in real time to adapt to whatever you're seeing. So all of this processing could be done in real time. So you cut yourself, you don't see the wound anymore because that's nasty, so that's fine. And then you never see anything that's really dangerous or really disgusting. And then the one day where you need to actually maybe understand that this is not something okay to do, like harm someone else, you won't, because the glasses will just filter it out for you, and that's scary. It is, because that is sort of the ethical part of it. It's like there's a lot of good that can come from reducing the amount of trauma that people experience.
But also a lot of drawbacks. Yeah, totally. But yeah.
And then it's like, who holds the tool?
Yeah. That's always the complicated thing. That's why we try to conclude at the end of the TEDx, saying that this is not something that we want governments to control or organizations. This is something that needs to be like user-based all the time, because we should be the one drawing the limits. I mean, of course, there's like moral codes in society, and there's laws, and this is but like you can expect that most people will behave in a similar way because of these moral codes actually.
Yeah.
So they would probably just try to filter out things that they don't need to see because they don't really want to, or they want to inform themselves but not be disgusted. But then we'll stop it at that, hopefully.
Yeah. Is there anything that we haven't talked about?
Don't think so. We've covered a lot already,
Yeah.
right? That was intense.
All right, I will add some links, like your TED Talks and all of that stuff in the notes, so everyone can
thanks.
go and follow. And then thank you.
Thank you for the
doing
opportunity.
this. And yeah.
Cool. Cheers.
Bye.
Bye.